we go back to the block diagram, notice that the string control is represented by a pink icon, and the numeric control, whose representation is long, is represented by a blue icon. The numeric indicator, whose representation we left as the default double, is represented by an orange icon. Now let's go back to the front panel and take a look at the right side, where we have a control and an indicator of the enum type. To place an enum control on the front panel, open up the Controls palette and go to Modern, Ring, and Enum. The string values of the enum can be changed by right-clicking on the enum control and going to Edit Items. Once in the Edit Items tab, you can insert a new item by clicking on the Insert button and then typing the string value you'd like the item to take on. You can move the item up and down the list to the corresponding number of your choice by clicking on the Move Up and Move Down buttons. To remove an item from the list, select the item and click on the Delete button. Once you have finished making your enumerated list, click on the OK button to exit the Items tab. Now that we understand the data types on our front panel, let's go to the block diagram and examine what else is in the VI. It appears that there are two functions that determine the numeric output on the numeric indicator. To see what these functions are, we can use the Context Help window. To bring up the Context Help window, click on the Show Context Help window button up in the upper right corner of the block diagram. You could also show the Context Help window by going to the toolbar, clicking on Help, and selecting Show Context Help. The Context Help window shows a brief description of whatever the mouse currently hovers over. As we can see here, the wire coming out of the string control is of the string data type. The function that the wire goes into is called string length. According to the Context Help window, it takes in a string as its input and outputs a numeric data type. The output is the number of characters in the input string. The second function is an add function, which appears to take in two numeric inputs and outputs the sum as a numeric data type. If you need to get a more detailed description of a function or its inputs and outputs, click on the Detailed Help link in the Context Help window. This brings up detailed help for that particular function. Now that we understand the functionality of our VI, let's examine its data flow. As it was mentioned earlier, data flow for our VI determines the sequence of execution. Looking at the block diagram, we can see that the input to the add function depends on the output of the string length function. This means that string length must execute before the add is able to. To verify this, we can use highlight debugging by enabling highlight execution. To enable highlight execution, click on the Highlight Execution button on the left side of the toolbar. Notice that the light bulb drawing on the button is filled in, indicating that highlight execution is now enabled. When we run our VI with highlight execution on, it slows the execution of the VI and shows the data flow with small colored beads that move across the wires. Notice how as each function executes, the output is also displayed. As we suspected, the string length function does in fact execute before the add function, since one of the add inputs depends upon the resulting output of string length. It should be noted, however, that this slower execution that takes place during highlight debugging is often desirable when you are finished debugging. For this reason, you will probably want to turn off highlight execution when finished debugging so that your code can run at full speed. To do this, just click on the Highlight Execution button. Notice that the light bulb drawing is no longer filled in, indicating that highlight execution is now disabled.